Okay, so thank you so much. It is an honor to close this series of webinars of SELGRA. So my acknowledgements to SELGRA, in particular to Dr. Akmaral and Dr. Margot. Thank you so much for this opportunity to talk a little bit about what we do here at INESC-TEC, Center for Robotics and Autonomous Systems. And also to have this opportunity to talk a little bit about ocean and space exploration, and my work as a researcher here at INESC-TEC. So I would like to take you to travel with me from deep sea to outer space. So let's go. I'm not going to lie. I would like to tell you the whole story, and to tell you the whole story, like I was saying, I cannot lie, because one of my driving forces and the main driving forces is to explore extreme environments, like you see here, from underground to fly to dive in the ocean. So I think as a Portuguese, and since the beginning of centuries ago, our navigators that wanted to discover and explore. So I think this is something intrinsically connected to the Portuguese, and also to Spanish people, but also intrinsically connected to humankind, to you that are here listening. And I think that you will agree with me. We want to explore, we want to discover. So it is something that is, I believe, that is one of our driving forces in our lives. So in 2018, I became, and to start telling all the story and to present this amazing program, in 2018, I became the first Portuguese woman to finish with success the scientist-astronaut program supported by NASA. Since then, in Portugal, along with other colleagues, I have been promoting human flight and robotic and human exploration in Portugal, as well STEAM or STEM activities. And this program, what is so interesting, and I would like to present to you a little bit of its background, is that they prepare scientists to do suborbital flights. They prepare the candidates to do these suborbital flights that we see very often happening with Blue Origin, Virgin Galactic, etc. But also it has something interesting for me, because the geosciences field was very wide. The program is very interesting because it has a broad range of applications, from the study of mesosphere, the study of noctilucent clouds, which are the highest clouds in the Earth's atmosphere, more or less 83 kilometers, 50 miles, and are observed slightly below the mesopause in the polar summertime. The clouds and the mesosphere are very important because they can give us clues about the entry and re-entry of spaceships. They can give us clues also in terms of climate changes and climate models. So, and even about the atmosphere in other planets. Of course, there was a strong component in terms of technology and instrumentation. This was also one of my driving forces, to learn more about the probes that they develop, to learn more about technology that they use, because I wanted to bring that know-how to my institution. And of course, because I'm an engineer, my background is geotechnics. I'm a geotechnical engineer with a PhD in geosciences, and I wanted to learn more about issues that I do not have any domain, like human physiology, aerospace medicine, to learn about spacesuits and extravehicular and intravehicular research. So this program is great to do some astronaut training, to learn more, and to learn about space exploration. I had the opportunity to be in several locations, in several places. One of them where we carry out our scientist astronaut course is at the Embry-Riddle Aeronautical University in Florida, United States. One of the most prestigious universities where a lot of pilots and astronauts did their degree, but also I had the chance to be, and I will show you more ahead, in the National Research Council of Canada. I had the chance to be in the Flight Research Laboratory in Canada, and also some of the trainings they also take place in the survival systems in Groton in the United States. So a lot of trainings that my colleagues do, they are carried out in Groton. So just an overview, amazing instructors from NASA to ESA. I would like to highlight Dr. Jason Raymuller, the executive director of this program. He was involved in the Orion, in the study of Orion capsule. José Hurtado, Dr. José Hurtado from El Paso University. He's the NASA instructor of the astronauts from NASA when they are doing their trainings in terms of planetary geology. Dr. Aaron Persad, an amazing physics from MIT, and for example, Dr. Armin from the Jet Propulsion Lab of NASA. So a lot of instructors, good quality of instructors and professors, and we have learned a lot in this course. Just a quick overview of this basic course of scientist astronaut, for you to have the whole image and the whole picture of this program. So we have the opportunity to do high altitude simulation and slow onset hypoxia effects inside the hyperbaric and hypobaric chamber. So we are inside to understand with the doctor outside, monitoring all the stages and all the procedures. We simulate that we are flying, and we have this simulator, and we try to understand inside when we simulate that we are 20,000 feet, we can understand our own symptoms of hypoxia, which can variate from people to people. Each one of you can have different symptoms, and that happened. My colleague from Mexico, my colleague from United States, they crashed the plane in their simulation. They saw everything blue, and my only symptom was my face was burning. So this is really interesting when we are talking about astronaut trainings and pilot trainings, to understand which are these symptoms of hypoxia, for us to understand in which altitude do we have these symptoms, to put our oxygen mask and to prevent fainting and to happen something bad. Another training, amazing training, is to use, I had the opportunity to use a spacesuit from Final Frontier Design. So it was amazing to understand all the systems, all the subsystems, to go inside the simulator, to have my pilot in my left, and to understand how to do a suborbital flight simulation, and to launch the probe, to recover the probe, to take some pictures to the mesosphere, to understand how all the procedures go in this type of suborbital flights and missions. Another training, acrobat flights. which allows us to understand the G-forces experience, to have the recognition and acclimatization of the body and vestibular system to G-forces. And we do a lot of maneuvers and to feel 0G when our hair is flying, to feel minus G, and to feel the positive G forces, which are the ones that we feel when we are going to space, when real astronauts are going to space. So this was a quick overview of the basic course. Of course, I fell in love. I wanted to learn more and more, and I had the opportunity to be with Dr. José Hurtado, the same instructor of NASA, and I had the opportunity to be in Flagstaff, doing some lunar analog environment training. And we had the opportunity to be here in the San Francisco volcanic area, where we learn a lot in terms of planetary geology. We learn a lot, we used a lot of equipment and technology, and it was really interesting because this program allows for us to carry out specific trainings. This one was really, really interesting and really exciting. I brought with me some rock samples that fly with me from United States to Portugal, and then from Portugal to Canada, where I had the opportunity to carry out, to develop an experiment related with planetary geology and rock hardness. And I had the opportunity to carry out a microgravity campaign, parabolic flights inside this amazing Falcon 20 that belongs to the National Research Council of Canada, and which is prepared for us to fly and to do these parabolic flights. And as you know, depending how the pilot puts the nose of the Falcon, we can have sorry, forgive me, we can have microgravity environment, we can have lunar parabola or Mars parabola, depending how he does the maneuver and how he puts the nose of the Falcon. So this was a great opportunity. In addition to several experiments that we brought on board inside the Falcon that you see here, which is very well prepared for us. We do electroencephalography, was also used in one of the subjects, in one of us, several sensors to measure pressure, in situ to make an electrocardiogram, studies related with human physiology, biomonitor, but also motion sickness, etc. We also use a headband, exoskin and astroskin to monitor. And also you see here this green solid, which is a green solid rotation experiment. So this was not a space, this was not space tourism. This was a great opportunity to bring with us a lot of experiments. And as you can see, more payloads, you can see here, it is worth to show you, you can see here the sand behavior in microgravity from my colleague from the European Space Agency, Bethany from Canada. She had the possibility to understand how is the behavior of sand in this kind of environments. Then you have here my colleague, Akram from the German Aerospace Center with a solar panel, a modular nano-satellite power system. He wanted to see the behavior of the opening and closing of this extendable solar array system in microgravity. We also had, you can see there in the same experiment where you see the solar panel, also the the extendable the handle, the dancing T handle in 0G to see if you can look in YouTube to see some of these experiments in the IIAS, inside the IIAS, and it is really interesting to understand this dancing T handle in 0G. Also from MIT, a lot of experiments with fluids, configuration experiments, and also from here 15 young girl under the scope of POSSUM 13, a student with 15 years old that won the opportunity to fly her experiment related with magnetic forces in microgravity. She wanted to test electromagnetic levitation. In order, her motivation was in order to create artificial gravity. So these are some of the experiments that we brought on board inside the Falcon, and imagine a lot of experiments, a lot of parabola to bring a lot of information to Earth. So my experiment, I had the opportunity to bring EcoTip. EcoTip can help us measure rock hardness. So my goal and my motivation was to understand the behavior of this kind of equipment that is usually applied in civil engineering applications for construction and engineering and architecture on Earth. And I wanted to understand its behavior in microgravity and lunar gravity in order to apply in experiments, in order to develop future technologies to have a space-proof EcoTip in this kind of environments. And as you can see here, it was a great opportunity. I brought with me more than 500 measurements in these two types of rocks, sedimentary rocks and volcanic rocks, and it was amazing. It was a great opportunity to understand the behavior of EcoTip and this kind of technology in microgravity and lunar gravity. And this experiment was so well featured by me, by our colleagues, that we call the attention of Screening Eagle company, one of the leaders in the world that develop this kind of equipment, they develop EcoTip, and they were very interested in expand their applications to other kind of environments, to microgravity and lunar gravity, and who knows, one day to have one space-proof EcoTip to measure rocks and rock surface on the moon. So they were really interested, and we were even part of one of the chapters of their catalog in terms of hardness, rock hardness. So it was really interesting. We used the data to publish the preliminary results of this experiment. It will be published next year in 2023 in Springer Nature journal. With my colleagues from the United States and Canada, and with my colleague, Dr. Aaron Persad from MIT. And it was a great advancement in terms of rock hardness in lunar and microgravity environments. So we are really looking forward to see our published research in Springer Nature. So, of course, we had in mind a lot of ideas. We want to put EcoTip, to integrate EcoTip in spacesuits. We want to integrate EcoTip, for example, for extravehicular activities, when astronauts go to do their activities and want to go to the moon or on Mars and want to in situ measure rock hardness, and to understand when we are talking about construction and engineering and architecture on the moon and on Mars in extreme environments, we want to understand. And when we are talking about, for example, Artemis program, when we talk about establishing base camps, we need to understand the foundations, we need to understand the geotechnical characteristics of our soils and our rocks. So this could be a great opportunity to integrate, for example, also ecotype in landers, in rovers. So because of that, and because of all this, everything started after our experiment in microgravity, in these parabolic flights, and we really kept the attention of several companies. One of them, yesterday we saw iSpace launch their lander Hakuto Air for the moon with SpaceX. So in this couple days we will see the first private company to get to the moon. So we draw the attention even to iSpace. We submitted a project under the scope of raw materials, and we will resubmit again with iSpace and other colleagues and other partners to develop an ecotype for space and extreme environments, and to have a rugged version that can solve problems on Earth, to use underwater, and of course it is important to test this kind of equipment and technology in microgravity or lunar or Mars environments. So we wanted to have a rugged version that could be used in mining industry, in underwater, in our underwater robots to measure the geomechanical stability in caves or mines, and also to have a space-proof ecotype. So we will resubmit again this project, and of course this brings us to these similarities between space exploration and ocean exploration. And you can see here there are a lot of offers under the scope of this program, POSSUM project, or the International Institute for Astronautical Sciences, and other courses and training programs are, for example, underwater. And you can see here the training, helicopter underwater egress training using a modular egress training simulator to do trainings in terms of emergency spacecraft egress. Also sea survival training in terms of sea survival when astronauts arrive and fall in the ocean, like we saw that yesterday, the Orion capsule arriving to the ocean. So emergency situations in case of egress, handling of signaling equipment and techniques to avoid hypothermia. So a lot of trainings related with underwater, with situations in case of egress, you can see here. Also this year we had the opportunity to offer this course, EVA 105, Fundamentals of Underwater Analog extravehicular activities, and it was really amazing. I had the opportunity to speak with some of the colleagues that carry out this course, and they say that it is a unique experience. And several researchers conducted underwater AVA tasks underwater, inside the water, new spacesuits, introduce new methods, operations and opportunities for learning, from downing procedures to mobility to overall performance. And our team, IIAS team, spent a combined total of 20 hours testing these suits underwater. It was really amazing. I had the opportunity to see remotely and talk with my colleagues, and it is really amazing how underwater and the buoyancy can really simulate the microgravity conditions, and we can learn a lot underwater and do a lot of trainings in this kind of courses. Also here, a publication from our colleague, Professor Rui Moura. He had the opportunity to do this courses and these trainings that you saw previously, that I showed you in terms of sea survival, egress trainings, etc. And from that biometrics aspects of training in Groton in the United States, they compared the performance results in relation to body dimensions and biometrics of body parameters and vital signs via Bluetooth. So it was a great opportunity to gather a lot of information and data, and they recently published this article resulting from this training and research in spacesuit development. And because I wanted to show you that space is for all, like I used to say, and like we hear so many times, space is really for all. And this is my colleague, Dr. Kelly Gerardi. She will have the opportunity to fly very soon with Virgin Galactic and take with her several payloads. In fact, Dr. Aaron Persad from MIT, he's a researcher also at the International Institute for Astronautical Sciences, and presently he is supporting Virgin Galactic to take several scientific payloads on board the spaceship. And he is also an integration engineer for the Polaris Dawn Axiom SpaceX mission. So this will be, this is for you to see how space is for all, is for you, is for me, is for all nations. And this will be a great opportunity. I'm looking forward to see my colleague, Kelly Gerardi, to fly very soon to do a suborbital flight. And she will not do only space tourism. She will have the opportunity to take with her a lot of payloads and experiments that will have the opportunity to fly with her. And payloads like this one. This payload belongs to Professor Rui Moura, my colleague here also at INESC-TEC. And Professor Rui Moura won the opportunity with MIT Portugal and Blue Origin to fly his experiment related with geophysics. So inside this box, it's a lunar regolith, simulant lunar regolith inside, and it's a project within the field of planetary geology. Of course, I would like to tell you a lot more and to give you more results, but unfortunately there was an anomaly. This was in September in this last New Shepard mission, and unfortunately there was an anomaly, and the mission that carried more than 36 payloads from all over the world, one of them from Portugal, didn't get to space and didn't do the suborbital flight and didn't get to the mesosphere. But very soon I hope to tell you all about it and to have more results and to show you everything about this experiment about lunar song. Ocean exploration, engineering the sea. Let me just spend these last minutes to show you what we do here specifically and which is our core. Our core is underwater technologies. CRASH, the Center for Robotics and Autonomous Systems, belongs to INESC-TEC. With these all, we are located in Porto, and we are an R&D non-profit research center and technology interface institution. And INESC-TEC has a lot of centers, different centers, and we are related with robotics. And our center make robotic and other autonomous systems able to operate in complex and unstructured and dynamic environments. And of course, we have these research lines that you see here. I'm not going through all of them, but I would like to highlight that our core core, our main expertise is underwater environment, also the ocean, and the expertise. My colleagues are very, very good in navigation and control, positioning. So this is the core. Of course, we have a new research line, which we call Space Georobotics and Geo-technologies, that I'm going to show you more ahead, but it is related with robotics applied to these geo applications, let's say like this. And of course, these are some of the pictures and some of the aspects of our facilities. We have 2 test tanks where we can bring to the limits, and we can test our robots and bring to the limits. Also 2 hyperbaric chambers, 750 bar and 400 bar, 2 hyperbaric chambers where we can test and push to the limits our robots. We have production facilities, CNC, 3D printing, etc. Also, it is important to highlight that our facilities here is also can support our research, can support our students from the master of the branch in electronical engineering, and in terms of the branch of autonomous systems. So they can breathe technology and they can breathe science here with us in our research facilities. So this is also very interesting because we are involved in several projects and we can involve also our students. And this is very good because they can be integrated in this and participate in several lab research activities, to have international networking, to participate in several robotics competitions, etc. We also have a research ship for testing marine technologies. This is Mar Profundo, deep sea, now is ready to make science and to help us to develop technology. So we are looking forward to go to the sea, to go to the ocean, and to bring our robots, and now to do some missions in the ocean, and to have this opportunity. Of course, like I was saying, and because this presentation is about, I think that it's more than proof. You saw the similarities between underwater and ocean and space exploration. I think that you can see all these similarities and how we can learn so much on Earth and underwater, and test our technology underwater to future applications in space. And we want to develop here this new research line that I was talking about is very, very close to develop technologies to extreme environments, to work in space, sea, earth interaction. So we are really, really interested in develop technologies for that. Following this idea of working underwater and working in space, earth, ocean interaction, we had the opportunity to develop and we won an European project. And after the European project, we developed a robot which was an amazing robot that explored old flooded mines in Europe. So when the project ended, we had the opportunity to submit the project to the EIT Raw Materials, which is a body of the European Commission, and we won an upscaling project to improve our robot. And the main goal of this project is to work in challenging scenarios, to map, to improve our perception and navigation and localization of our robots and our techniques. And UNEXUP, we developed a lot of robots until achieve this one. This one is our UX1 Neo. It is an amazing robot that can explore old flooded mines, underwater environments, caves, etc., environments with water, but with a lot of potential. He has inside he has a lot of 2 sonars, he has lidar, he has sub-bottom profile, he has a lot of sensing technologies, cameras, etc., that help us, and he can autonomously decide if he's going to the left, if he's going to the right. And we have here an amazing robot, and we can say that UX1 Neo is one of the most technologically evolved underwater robots in the world. In fact, a few months ago, INESCTEC broke a world death record in the exploration of flooded caves. Our team, which is an honor to work with them, I'm so proud of them, a team of researchers from INESCTEC, they had the opportunity to set the record for exploration of the world's deepest natural cave, the Harnis Abyss in Czech Republic, by sending our robot up to 450 meters. So this was a great opportunity. The robot was able to autonomously navigate, localizate, to know his location, positioning, etc. And it was a great opportunity also to map this amazing and deepest natural cave. Another future perspectives and future geotechnologies. In fact, we are finishing this project related with LIBS, laser-induced breakdown spectroscopy. Perseverance rover brought with them LIBS technology, and this technology that uses a short laser pulse to create a microplasma on the sample surface. It is a great opportunity to test in situ on Earth, to solve problems on Earth, but who knows, we can use our portable LIBS. We will have 2 versions, a portable LIBS, with a very accurate geodatabase, and we will also have an underwater LIBS, a version underwater that can be easily integrated in our robots. So this was the first prototype tested by potential customers and prepared for field tests here in Slovenia in October. We had the opportunity to test and to see how our LIBS technology works. And finally, just to very quickly in these last minutes to tell you that this research line is very close to space geo-exploration, to space mining. We are very interested in developing technologies to do space mining on Mars, on asteroids, on the moon. And of course, when we talk about these geotechnologies and robotics, we are talking about even companies that are already developing georobotics to mine asteroids and to go to the moon and to go to Mars and to be autonomous, and a swarm of robots, as you can see here. iSpace also have a master plan. We saw yesterday they are almost arriving, the first Japanese and private company that is working very closely with SpaceX. They have, in fact, they acquired and they signed a contract with SpaceX, with NASA, to acquire regolith, lunar regolith. So they will be the first private company to acquire and to bring to Earth and to sell to NASA lunar regolith. So it will be, we are living exciting times, and we are living really to see all of this evolution of technology is really amazing. To detect this kind of geotechnologies that we want to develop and that we see a lot of companies developing is to detect this kind of geological structures, these lava tubes that astronauts can use to protect themselves from radiations, to use geophysics techniques, ground penetrating radar, etc. We can use a lot of geotechnologies to detect these kind of geological structures, which are so important. And of course, this is one of the example. This is one of my favorites asteroids, Psyche. It's worth more than the world global economy. So that is why so many of us and so many companies are interested in mining asteroids and doing developing technologies in terms of space resources and space mining. In fact, Professor André Dias, here, a researcher at Inesctec, and I, with my colleagues from MIT, United States, we submitted these kind of projects, knowing the importance of these kind of technologies, working in microgravity to support operations inside, for example, the International Space Station, like many robots already tested inside the ISS, such as Simone, Sora-Q, Astrobees. So we conceptualized this project. We submitted to the MIT Portugal program as an exploratory program. In fact, I have it here, I can show you. This is the 3D model of our robot. You can see here, it is based in this smart orb. It will be a smaller one. Is based on the UX-1U that you saw previously, the big one. And our goal is to develop this smart orb system that can explore, that can be used as a scout robot, can support geoscientific field work on land or underground, or other future applications such as space debris detection and classification. So our smart orb, our Sentinel orb, will be able to fly in microgravity environment and lunar gravity environment and be able to explore. So just to finish, well, what about me? Unfortunately, due to COVID, some of the courses stopped, but this year they started to carry out a lot of courses, and I want to pursue my space training and qualifications. I want to learn more and more and to bring that knowledge to my institution. I will be next year in this amazing analog area in Utah, in the Mars Desert, in the Mars Desert Research Station in Utah, which is an analog, a Mars analog, and it is operated by the Mars Society. So I will be the only Portuguese with 6 colleagues from the United States, and it will be amazing to test some of the technologies and to do space trainings here in this amazing place. And this is just to show you how I really find amazing how Earth has these fantastic places where we can prepare ourselves to go to space, these analog environments, not only in Utah, even in Azores, in Fayal Island, Capelinhos volcano. We have here a great analog, Hawaii, Flagstaff in the United States, etc. A lot of analogs on Earth that prepare us to go to space. So we are really interplanetary species like Elon Musk used to say. Just to finish my last slide, to tell you that it is really important to be with you today, to disseminate, to communicate, to show even from kindergarten to young students, to show how challenging the limits of space and technology is, to show what we do here at INESC-TEC, to show the geotechnologies that we develop for space exploration and space trainings. Here, Professor Rui Moura, with Nicole Stotz, she was called the artistic astronaut. She is a veteran astronaut from NASA, and she was the first astronaut to paint in space. So here he is in the cancer ward of Portuguese Oncology Institute of Porto, with the children that contributed with their painted piece of ILC Dover fabric for the spacesuit, which is in exhibition in the United States, in the Foundation for Arts and Science that belongs to Nicole Stotz. So it's amazing also to share and to motivate small children to space exploration and engineering, technology, science in general. And also to show you this initiative, Space for All Nations. Portugal is an emergent space nation, and we even celebrate a memorandum of understanding with the International Institute for Astronautical Sciences, with our colleagues from the United States, to work very closely with them, with Canada, with nations that have a big culture in terms of space exploration and a lot of knowledge. And we developed this initiative that bring nations like Ghana, Indonesia, Cabo Verde, Portugal. We want to learn with the best. So this is also a great initiative. I'm the co-chair of the initiative that aims to join forces between all the emergent space nations in the world. So thank you so much for your attention. This last picture is an image from our last demonstration in Brussels a few weeks ago in our final conference of UNEXA project. So, and I think that it shows very well and how interesting it is, this interaction, human and robotic interaction. So thank you so much for your attention. It was an honor to close this series of webinars, and it was really an honor to share with you. And thank you so much once again to SELGRA for this great opportunity. Thank you so much.
Thank you very much, Ana. It's amazing presentation. Yeah, I know personally Ana, she's really like that, very enthusiastic, very big believer.
And forgive me because I know that I'm not 100%. So forgive me because I had a flu a few weeks ago, but I'm not getting better. So forgive me for the cough and for this awful voice. So forgive me.
Everything was perfect, and from my side, I have nothing to complain, for sure.
Thank you so much.
I didn't find any questions here on the chat, so I want to ask if anybody wants to ask something. You can raise your hand, or if you want, please let us know. Basically, if you have any kind of questions.
I'm going to start because I do have one question, if you don't mind. Can you tell me more about what kind of tests you're going to do during your analog missions in Utah? Like, are you going to use some of the technologies you present to us? Can you tell me more about that?
Yes, in fact, we have one more that is not yet finished, Margot, but it is related with the rock sampling device. We are developing a robotic arm and a rock sampling device, and I would like very much to bring that with me. But more than that, you saw all that research related with planetary geology. So I want to do the same thing that I did in Flagstaff and in the parabolic flights. I want to bring with me, I want to compare the rock hardness on Earth and then to do another parabolic flight and bring with me some rock samples and compare and to find some they are interconnected, these studies. So I want to find some connections between these studies and to have more data to improve the development of the space-proof ecotype in the future.
Yeah, that's really amazing. I think
Okay.
analogs are really, really useful for that. Like for geotechnologies and everything, because obviously
Exactly.
we have soil and we have ways to test it with EVA suits and everything. So it's
Yeah,
amazing.
exactly. The
Analog.
perfect, Margot, the perfect situation is if we had the chance to go to the international, to send our experiment and to have our experiment in the International Space Station. But if we do not have that opportunity, the best way is parabolic flights.
Yeah.
We only have a few seconds, or suborbital flights, like the one that my colleague will have the chance to do. We will have more minutes to do experiments. So I think that this is the only way from Earth to have more data in terms of microgravity environment, you know. So this is the only way.
Thank you.
Thank you, Anna. I have also the question.
Yep.
Here, a question is about, you said about the space for everyone, you have this kind of training for astronauts, a postdoc program, right?
Okay.
Is it available for everyone to apply? What kind of conditions? Can you tell a little bit more about that? Maybe somebody is interested here in Victoria.
Yeah. I was almost forgetting. I'm sharing with you some interesting links for you to analyze and to see the potential of this program. The basic course, you do not have to have a degree. They have an advanced training academy for younger students that they, if you don't have finished your degree, you can do the Scientist Astronaut Academy. Okay, if you have a degree or a master or a PhD, you do the Scientist Astronaut course, and this is the basic course. And then I already put here, please explore. You will see that the several courses that are available could be related with geosciences, with human physiology. With Dr. Eric Seedhouse, you can learn more about life support systems. You even have courses related with aerospace medicine. You have microgravity campaigns and the microgravity flights that they do. You have the planetary geology course. So you have a lot of spaceships related course. So you can learn everything, all the fields related with space industry are there, and you can learn more, and you can do specific courses to learn more after the basic course of Scientist Astronaut. Let me just highlight this. POSSUM project and the International Institute for Astronautical Sciences is one of the many programs that you have available, okay, to do suborbital flights, to learn more about space exploration. Because you are a citizen, you are a scientist, you are a researcher, and you look for chances to do networking and chances to learn more and to have the opportunity to do experiments. And this program, for me, is one of the best ones. And as you will see, but please be free to explore. I see that Margot already put the links. Be free to explore, and be free also to reach out because Akmaral already knows some of the elements of some of the researchers that are involved with this program, like Dr. Aaron Persad from MIT. And it is really amazing, this networking and how we can learn with each other. And you saw, if it wasn't this program, I wouldn't have submitted an exploratory project with them. So we can learn a lot with them and with each other. So, and of course, I'm looking forward also to work with Akmaral. We never know, so in the future. So let's see how this goes. And if we win these projects, I'm sure that we will have the chance to work together.
If anybody does anybody have questions? If anyone, I think it was amazing, interesting, exciting presentation, full of opportunities for anybody that fits to anybody who is interested in any kind of microgravity and gravity-related research, who wants to be astronauts, who wants to do research in deep sea. It's really like a very exciting presentation. I'm very, very thankful to Ana to share so much information to us. It was very informative. And if no one else have a question, we can start to close this webinar.
No, I just wanted to add and to tell you, Akmaral, you are absolutely correct. Thank you for pointing that out. I just wanted to show with my presentation that space is really for all. It's for us, it's for you, and it's for all nations. And with this kind of programs that exist out there, we can learn so much about space industry. And I used to say that we don't necessarily need to go to space. My goal wasn't to be an astronaut, nothing like that. I tried, but I didn't move forward. But this to do something in terms of in space industry is not necessary to be an astronaut. You can do a lot of things in the space industry: thrusters, spaceships, life support systems, biomonitoring, human physiology, aerospace medicine, engineering. Jesus Christ, so much fields of research that we can develop and work in space. And who knows, you saw, we never knows that if Portugal will have a technology on the moon. So
I think it's only lacking the desire. If you want to do something with space, there's like really space for everybody in space.
Yes, exactly. Thank you so much.